In this video, we'll continue to explore values and data types in Swift. So I've got a playground open again with the foundation module imported. And the first thing I'm going to do is declare a constant, call it greeting, and initialize it with the string hello. I won't use a type annotation so that Swift will infer the data type of string. The reason why I am using a constant with the let keyword instead of a variable with the var keyword is because I'm going to create strings to greet different people. Now the greeting will never change. The name of the person being greeted will, but since the greeting will not change, it should be a constant. And this is a rule of thumb in Swift. Anytime you create a value that will not change, it should likely be a constant. In other languages, constants may be thought of as values that apply to a large or even global scope. However, in Swift, even temporary values created on the fly, given that they do not change, should be created as constants. And we'll see an example of this later on, as Xcode 7 is able to detect variables that do not change value and suggests that you use constants instead. So now let's greet someone. How about the world famous John Doe? Swift will let me concatenate greeting with the string John using the plus operator. And the result should be hello John, as seen here. However, some might be getting a result like this. Hello John, all one word. Now the reason is obvious. The string John should begin with a space. And this is a common mistake when concatenating strings using the plus operator. We as humans don't think about starting a string with white space. In addition, we've already included white space around the plus operator, but that was for readability of the code, not the output. So all of this white space can get a little bit confusing. And the reason I'm making a big deal out of this is because this method of concatenating strings, while simple, is not always readable. So to compensate, Swift has a method of string interpolation, which allows you to create more readable string templates. So to greet John using string interpolation, let's put the following in the playground. And we see this time we get the result that we want, hello space John. So what's happening here is we're surrounding value names with this backslash parentheses syntax, and Swift will place whatever the value of this name here is into the string. In this case, greeting is equal to hello, so we'll place hello here and we'll get hello John. So the result is the same as using the plus operator to concatenate strings, but the syntax is much easier to read. And this is also more readable than some formatting methods found in other languages, because with those you have to manage a position-based series of values to replace placeholders in the template string, and trying to switch back and forth and manage the two can become error-prone. I'll be using string interpolation almost exclusively throughout the rest of the series. And you're not limited to just constants and variables in string interpolation either. You can access properties and methods as well. For example, take a look at this. All strings have a property characters that represents the individual characters in the string, and so the count property represents the number of items in the character property. And then we can see that hello has 5 letters. Now keep in mind that with this kind of power, as the cliche says, comes great responsibility. You don't want to try to do too much in here, because then not only does the code become unreadable, but it becomes error prone and it's just bad style. So we can also perform math functions as well. I'm going to bring back the pi constant from last time. And also I'm going to create another constant to represent the radius of a circle. Now I'm going to create a string to show what the area of a circle with radius 10 is. But this doesn't work. Why? Well, if I click on the error marker, it's going to tell me that the binary operator times cannot be applied to operands of type double and int. And the reason is because Swift, again, will not implicitly cast types, so you can't multiply a double by an integer. So this is the same problem we saw last time, where what we need to do is, since we have an integer here that we want to treat as a double, we need to specifically tell Swift to use it as a double. And now that I've made that change, the code is fine and is going to tell me that the area of a circle with radius 10 is 3.14, is 314.159.